sketching functions is what we're going to look at in this video. So the way my videos work, I'm going to do the example on the left, which is I do. You are then going to press pause, and I've got an example on the right, which is you do. So we are going to start off by looking at sketching these three here. So the first one here, y is equal to x, is called the diagonal, and I'm going to sketch it on properly in a second, but it will look something like this. Okay, so it'll be a straight line diagonally like that. And with this, if you don't know what the line looks like, you can always plot a few points. You can have x and y, and you can say, well, when x is 0, what is y going to be? Well, since x is equal to y, it'll just be 0, 0, 1, 1, 2, 2. And essentially, when you draw this line, you can see both the values of x and y are equal. So if I use my red pen, if I put a red dot there to draw y is equal to x, it will roughly look something like this. It's just a sketch. Now, with the next one, if I use my green pen, the only difference here is we have a +1. And all this +1 means is we're going to draw the exact same line, but it's going to cross at 1. Okay, so it's also a good idea to label that on here, just so it's clear. So we're going to draw the exact same line. It's going to be parallel. It has the same gradient. By gradient, I mean the steepness of the line. And it's going to pass through 1, so that's that done. And then if I move on and I use a blue color for the final one, so again, hopefully you can see with this, it's just going to pass through the 3. So exact same line, that's parallel as well, and it's going to pass through, if I move that up a bit, 3. And yeah, that is all for that. So hopefully you've pressed pause and had a correct example on the right. So it's always good to start off with y is equal to x. If I start off with that, so we have y is equal to x there. Now it's going to pass through -1, so I'm just going to label that on. So -1 will be here. So if I label that on and put a line straight through that, again, make sure you are using a ruler to do this. And finally, I'll do that one in green. I'll put -3 down here, and that will look something like, well, it needs to be parallel. So let me just move that up a little bit. So something like that there. So moving on, now it's worth me pointing out that this x bit is referred to as the gradient, so the bit before that. So this has got a negative gradient. So before we had y is equal to x, we can just call that 1x. So the gradient before was 1. It's a positive 1. Now the gradient is y is equal to -x. Again, we can just write -1x. This bit is called the gradient. The gradient just tells you how steep the line is. And this time it's negative, so it's going to be in this direction. Okay, so if I draw on the first line in blue, it's going to pass through the center. So that's that done. Now the next line is a +2. All it's saying is it's going to cross through 2 up here. So it's the exact same line, but it's just going to cross through there. Now with the next one, it's just going to cross through 5. So if I just use a different color there, and that's just going to cross through 5. It's all parallel, so if I just move that up a little bit, there we go. That's that done. So again, hopefully you've pressed pause and had a correct example on the right. So if I do y is equal to -x, it's going to pass through 0. That is key, that it passes through 0. Now the next one, I'm just going to label that on. So that's going to cross through -2. And then if I just draw that line there, just going to make sure it's parallel. So I will just move that down a little bit. There we go. And the final one, we'll do that in blue. So that would be -5. It's going to pass through, and that would look something like this. There we go. So now moving on, the difference now is the gradient changes. So we now have a 2x, a 4x, and a 0.5. So the number before the x is called the gradient. It tells you how steep the line is. So if you start off nice and easy, so if you start off in this one, y is equal to x, we know that looks like this. Now, the next one, y is equal to 2x, is the exact same thing, but it's now a steeper gradient. The gradient is 2x, so it still passes through 0, but it's just steeper now. Okay, so now with 4x, if I just put that there, with 4x, we'll do that in blue. That's just going to be even more steeper than 2x. And now finally, with a half x, that's going to be less steep than 1x. So if this was 1x, bigger goes that way, getting smaller comes this way. So the line is going to be less steep. We'll do this one in black. That is just going to look something like that. It needs to cross through 0, 0, and it just needs to be clear that it's less steep. So that is that done. Now, I should also mention I have linked these slides in the comments down below, so you can print them off and follow along. So we'll start off with the first one. Nice and easy. There we go. The next one is more steeper in the negative direction. So we have a negative gradient. The next one is even more steeper. So that would be like that. And the last one is the least steepest, so just like that. If I just put a black dot there, so we can refer to the lines. Now moving on, we now have the intercept and the gradient together. So if we start off with drawing the first one, which is nice and easy, y is equal to x. Okay, so that's that done. Now if I move on to the next one, I'll do that in blue. We have 2x plus 1. Okay, so the first key bit here to notice is it passes through plus 1. So we're just going to label that one. We're going to say, okay, this line is going to pass through plus 1, and it's going to be steeper than the previous line because the gradient is now 2x. Okay, so it's not just going to be parallel. It's not going to be parallel to the last line because the gradient is steeper, so it will look something like this. So moving on, now the gradient's even more steeper, but it passes through 5. So I'm going to draw a line that's even steeper that passes through 5, and that's that done. And then finally, we have this line. It also passes through 5, which is already drawn on. So it's going to pass through the same point here, but it's less steeper, so it will look something like that because it's only a half x, so it's going to be less steeper. There we go. That is all of that done. So that combined both the gradient, which is this bit here, and the intercept. So I would always recommend starting off by looking at the intercept and then look at the gradient. So again, hopefully you've pressed pause and had a quick example on the right. So first one is nice and easy. That's that done. Next one, I will look at the intercept first. I'll label that on. So if I use my red pen for this, I'm going to label on the intercept. Now that's that done. Then I'm going to look at the gradient. If the gradient's the same, it can be parallel, but it's not the same. It's 4x, so the line is going to be much steeper. So it's going to be something like that. That's that done. Now moving on, again, I'm going to look at the gradient first. The gradient is -5, so that's going to be there. And it's even more steeper than the previous one. So, in fact, I'll just draw -5 a little bit higher up. So if I just put -5 there, it's only a sketch. It doesn't really matter too much, but it does need to be accurate in terms of where these lines are passing. So if I just fix this a little bit, there we go. Oh, no, almost had it there. Perfect. And then if I look at the final one and do that in black, so that also passes through -5, which is that point there, but the line is the least steepest of all. So I will just draw it like that there. That's that done as well. Now, moving on. So these are some really, really good questions. So I would recommend you press pause and have a think and have a go at these. So the way I look at this immediately is obviously you've got the equations down here and you've got the 3 letters there. I can see immediately what's different about these. If I just think about the gradient, this has a positive gradient, this has no gradient, and this has a negative gradient. And that's enough for me to solve this question because this one has a negative gradient. So it must be that line there because there's only one graph here with a negative gradient. Now, there's only one graph here with a positive gradient, so it must be this one here because that's got a positive gradient. So that must be B. Okay, so I've just used this bit of information here, the gradients, to answer these two. And obviously what you're left with is B because this here, it doesn't have no x value. So that means it's got no gradient. So this must be B. And apologies, I made a mistake here. I'm supposed to say A here. That was A. So moving on, we've got a slightly different question. Now the intercepts are all the same, if you notice that. 1, 1, 1. So we know that they're all crossing through the same point. That's fine. What's different? Well, I can see immediately this one is different to the other two. How is it different? It's got a negative gradient. So do any of these have a negative gradient? Yes, it does. This one does. So immediately I've answered C. So that means I've just got to answer A and B now. Well, what's the difference between A and B? Well, looking at here, they both pass through the same intercept, so there's nothing we can do there. But one line is steeper than the other. We can see that B is steeper than A. So B must be 7x and A must be 2x. Now, moving on. Again, press pause and have a go. So looking at this, immediately what strikes out to me, that's got a negative gradient. The other two don't. So I can immediately answer this one. That's that one there. Hopefully you can see the thought process I'm going through and doing this. Now next, they've both got a positive gradient. So I can't really use the gradient to too much help. They both look about the same. They've both got a gradient of 1. I can see that. So the only thing I can use is the intercept. So the intercept of this on the y-axis is a minus value because it's below 0. And the intercept of this is a positive value. So I know that A is going to be that one and B is going to be that one using just the intercept alone. So moving on, we're now looking at quadratic graphs. So the first one, x squared, that would look something like this. It crosses through 0. It's a curve. I can try to draw that a little bit better. It will look something like that. So that is that. Now that's that done. Now with the next one, it's the exact same thing, but it's going to cross through -1. So if I just write -1 there, exact same thing, but crosses through -1. And the final one, it just crosses through -3. Exact same thing, and it's just crossing through -3. So that is that done. And in fact, it shouldn't really be wider. Let me just draw that a little bit more correctly. It's the exact same thing. That's basically just been moved down. So I shouldn't be drawing that wide. I should be drawing it. It'll go through there like that and that. So it's the same graph. You're just moving it down. And on the right, hopefully you've pressed pause and had a go. So x squared, nice and easy. Now with the next one, you are just moving the same graph up to 1. So that's that one there. It's the exact same graph we're going to draw again. We're just moving it up. And the last one, we're just moving it up to 3 now. So we're going to label the 3, and we're just saying, well, actually, we're just moving that up. Now, moving on, we've got a negative now. So the negative just means it's upside down. So that's that. Now, the +2 means we're going to cross 2 instead of 0. So that 2's there. So again, it will look something like that. And the final one is just saying, well, it's the same graph passing through 5. That would just be something like that. Again, hopefully you have pressed pause and had a go at the example on the right. So that's that one done. It's now passing through -2. -2 would be there. And again, a good idea to label on -2 as well. And then finally, for the last one, that is passing through -5. Do that there. So now we start off the exact same. So we have x squared. Now with 2x squared, the graph gets narrower. Okay, so we're drawing the exact same graph starting at the same point, but it's narrower. And with 4x, it's even more narrower. So as that number increases, it just becomes narrower, narrower. So that's that done. So if I just put the colors next to them, so we know what's coming from. And then the final one is a half x. So half x just gets wider. So that's just going to be the widest graph or map. Okay, so that number at the front of the x squared, that's all it's doing. It's controlling how wide it becomes. So on the other side, it's the exact same thing. It's just in the opposite direction now. So we've got the x squared there, the 3x squared. So that would just be the exact same thing, a little bit narrower. The next one's going to be even more narrower. And then finally, we have a half. What color have we not used? Blue. That would just be there. So now moving on. Again, we can start off with the easiest. So that's x squared. That's that done. Then we have 2x squared plus 1. So it's narrower. And it also now crosses through 1. So we're going to have to label that one. We're now saying it crosses through 1 and it's narrower. And the next one is, well, it's even narrower and it crosses through 5. So almost something like that. And for the final one, it crosses through 5 and it's wider than all of them. So we could just do something like that. And again, hopefully you've pressed pause and had a go at this example on the right. So that's the first one. The next one is going to cross through -2 and it's narrower. The next one is going to cross through -5 and it's even narrower. And the last one also passes through -5, but it's the widest of all, so just be something like that. So again, some really good questions here for practice. So looking at these, what stands out to me the most is they all look the same, but where they cross the y-axis is different. This one is negative, this one is positive, this one is 0. So this one is going to be A. This one has a negative, so that's going to be C. And this one is going to be B. And what I've used here to solve this is that is negative, and I can see that is negative there where it crosses. That is a positive, and that's a positive one there. Whereas this doesn't have anything, which means it's +0 basically, and 0 is just going to be right there. So moving on. Again, some really good questions. What immediately sticks out here is this graph is upside down, which means it's negative x squared. So immediately I can answer this question. This must be A, right? This bit here doesn't even matter because this one is completely in the opposite direction to the other two. So now that I've done that, I've just got to worry about the other two. Now what's different here? This is positive, where the turning point is what we call it. And this is negative, where the turning point is. So that means the negative one must be C, which means the other one's B. So again, hopefully you've pressed pause and had a go at this. So all these graphs look the same. And the only difference here, really to be more correct, this should really, all of them should really have the same, should say +1 next to each other. So we know that they all cross the turning points at the same point, but they're all different. different in width. So this one is the widest, this one is the narrowest, and this one is in between. So the widest one must be C, the narrowest one must be B, and the one that's in between must be A. So if you would like some more practice on this, I have got a full worksheet on this linked down in the comments below over on my website. And if you found this video useful, I've got loads of other content like this on my channel, do check it out.